In the world of regression, there's a concept to know. Projection matrix P, also referred to as the hat matrix. Diagonal elements that make predictions flow. I hat equals PY. What does it mean? When P diagonal gets large, you'll see I hat changes dramatically. Small data shifts cause big prediction swings. That's what leverage ratio brings. Imagine observation space, not variable space, and dimensional vectors in their place. X columns M plus target Y. Linear regression projects, here's why. From n-dimension space we compress to n-dimension, nothing less. X creates the plane where Y projects down. Information compressed, mathematically sound. Imagine two-dimensional cross-section view. Standard basis U1 and U2. Here's what we do. Y equals Y1 U1 plus Y2 U2. Therefore PY equals Y1 PU1 plus Y2 PU2. Leverage, leverage. Diagonal power in the matrix. Leverage, leverage. How much Y hat changes when Y shifts. Pu1 equals H1 1 U1 plus H2 1 U2. Pu2 equals H1 2 U1 plus H2 2 U2. Leverage, leverage. The key to understanding shifts. Py breaks down to components clear. Y1 H1 1 plus Y2 H1 2 and U1 appear. Y1 H2 1 plus Y2 H2 2 and U2. You see diagonal H1 1 shows what Y1 can do. When Y1 changes, Y1 hat responds. H1 1 leverage creates the bonds. Off diagonal H1 2 shows the way I2 affects Y1 hat's display. Geometric understanding, here's the key. Vector dot product formula shows UI transpose PUI equals magnitude UI magnitude PUI cosine theta. UI transpose PUI equals HII magnitude UI equals 1, that's true. Magnitude PUI equals squared root of HII. Use a P as a idempotent property. P transpose P equals P, so neat. HII equals cosine square theta C. Leverage, leverage. Angle between axis and projection plane. Leverage, leverage. Smaller angles means bigger gains. Cosine square theta tells the tale. High leverage when angles get small. Leverage, leverage. Geometric inside never gets stale. Two-dimensional view makes concepts clear. When x1 x2 equals 1 1, we're here on diagonal line, balanced and neat. When x1 x2 equals 2 1, we meet a tilted plane closer to x1 side. Y1 y2 projected, here's our guide. Smaller angles amplify y1's effect. Outliers tilt the plane, that's direct. Leverage depends on conditions set. P equals x times transpose x inverse x transpose, you bet. Only x determines y, doesn't matter, test conditions fix. Leverage scatter, maximum leverage equals 1. Maximum of cosine squared theta never outdone. Minimum with intercept included in x. 1 over n, never excluded. Leverage, leverage. Range from 1 over n to 1. Leverage, leverage. Trace of p when sum is done. Trace p equals trace x, x transpose x inverse x transpose equals trace identity, and we boast. Leverage, leverage. Total leverage always n. Average leverage m over n. Normal distribution where we begin. 2.5 times deviation signals problematic observation. Stable predictions need balance, true. Leisure spread across points, not just a few. Y hat depending on many y values, better than single point that skews. Leverage ratio diagonal might shows prediction sensitivity right. From observation space to regression plane, understanding